Hi everyone, let's look at another question on circuits. The circuit to the right contains 4 identical light bulbs P through T. Assume the light bulbs obey Ohm's law and that all wires have 0 resistance. Rank the light bulbs in terms of brightness with brightest first. Be sure to indicate if any light bulbs are equally bright. As we mentioned, the brightness of the light bulb is related to the power dissipated in a light bulb. The power dissipated in a light bulb comes from P equals V squared over R. So I'm going to start with S light bulbs S and R. Because light bulbs S and R are in parallel, they have the same voltage. They have the same resistance. Therefore, according to the power dissipated equation, the power dissipated in both is the same. So I can say PS is equal to PR. That means that the brightness of R is the same as the brightness of S. Then I would compare the voltage across S and T together with the voltage across Q. The voltage across Q is the same as the voltage across S plus the voltage across T, because S and T together are in parallel with Q. That means that the voltage across Q is bigger than the voltage across S, and also voltage across Q is bigger than the voltage across T. This also means that the power dissipated in Q is bigger than Vs, and the power dissipated in Q is also, bigger than Ps, and the power dissipated in Q is also bigger than Pt, because the bigger the voltage, the bigger the power. They all have the same resistance. So, how about Pt compared to Ps? Well, if I look at this junction point, I can call this junction point D. If I look at this junction point, and the current coming through S, I call it Is, and the current coming from light bulb R, I'm going to call it IR. They join together, to create the current going through IT. So the current going through going through bulb T is therefore bigger than the current going through IS, because IS plus IR gives me IT. The bigger the current, the bigger the voltage at a constant resistance, because V equals I times R. So I can say that the voltage across T is bigger than the voltage across S. If the voltage across T is bigger than the voltage across S, that means that the power dissipated in T is bigger than the power dissipated in S. Perfect. So far, if I look at all these equations, all these equations, so I can say, look, PQ is bigger than PT is bigger than PS, which is equal to PR. So I'm almost there. I've almost solved the question. Now I have to look at the power dissipated in light bulb B and compare it to the other ones. So the current coming out of the battery, that current will go through light bulb P. And that current then will be divided. If I look at this junction point, and I'm going to call it junction point, let's say Z. If I look at this junction point, that current that is going through light bulb P, it will be divided. To a few currents. So therefore the current in P, in light bulb P, is going to be bigger than the current in other light bulbs in here. As you remember from Ohm's law, the bigger the current, the bigger the voltage having the same resistance. So I can say, look, the current through light bulb P is bigger than the others, therefore its voltage, the voltage across of it, is bigger than the others. Having the higher voltage means that we're having the power dissipated, having the higher power dissipated, and at a constant resistance. That means that the power dissipated in P is the highest. Therefore, light bulb P is the brightest, then Q, then T, and S and P, S and R, they are going to be the DMAS, but they have the same power dissipated in them.